To meet our next laureate, we switch to the Naval Postgraduate School in Monterey, California. Under the spotlight, Professor of Physics, Stephen Garrett. For more than 10 years, Garrett and his team have been working on a refrigeration system that could revolutionize an industry so long dominated by ozone-depleting CFCs. Garrett's solution is thermoacoustics, a refrigerator powered by sound.
One of the advantages of going with thermoacoustic refrigeration is that it's based entirely on inert gases, and they have no toxicology, and in fact they have no environmental consequences either to the ozone layer or to global warming.
The project is based on a principle well known to glassblowers, where a change of temperature from one end of the tube to the other can cause audible sound vibrations. Garrett's system reverses the process. By transmitting sound waves through a heat exchanger, one end becomes hot, the other cold. Insulate the cold end, and you have a cooling system. Simple. Well, the U.S. Navy liked the idea and commissioned Garrett to build STAR, the first space thermoacoustic refrigerator.
Over the years, we've built several different styles of resonators. This one is from the late 80s. Behind me is one that is a later version, and it's wrapped with thermal insulation just as it was when it flew in space. And this ended up in here, and this entire device went into orbit in January 1992.
Later this year, an updated version of STAR will be tested on board Spacehab 2.
The reason that thermoacoustics was attractive for small spacecraft applications was that it has no sliding seals and it has a very small amount of moving mass and hence very low vibration.
But what about cooling systems back on Earth?
Well, everyone in the appliance industry is faced with two problems in building the next generation of refrigerators and air conditioners that will be environmentally safe and will also be efficient.
But with CFCs officially banned in many countries from 1995, time is running out. And while others experiment with alternative methods, Garrett, through his private company, has been working on a commercial system based on STAR.
What the company did was allow me to take what I had learned by building these refrigerators for space and apply that to commercial requirements, invent various improvements and changes that would take that from being a technology that was useful for cooling electronics in space to a technology that was useful for cooling your house in the summer.
Although it's a project that's won Stephen a Rolex award, it would be wrong to assume we will all be refrigerating our food acoustically in the foreseeable future. The principle is proven, but as Garrett freely admits, there's still some way to go.
The way I see it is much like the Wright brothers. Their first flight was a mere 200 yards. But what it did was not create the airline transportation industry or airmail or anything else. What it did was it shifted the debate from whether or not heavier than air, manned, powered, controllable flight was possible to who can do it better. So what I want to do in the next 6 months is shift the debate. I want to shift it to not whether or not thermoacoustics is a contender for replacing chemical refrigeration processes, but that it is a possibility, and the debate shifts to who can produce the components, who can do the assembly more efficiently, more cheaply, more quickly.
Garrett's team are blazing their chosen trail of thermoacoustics. Their work, the perfect blend of academic research, of commercial application, and of dedication.
During the day, I'm in the laboratory working with my colleagues and my staff and my students on the project of the day. At night, I feed my children, read to them, put them to bed, and by 9 o'clock, I'm back in my office. There is not a lot of room in my life for entertainment outside my family and children, but it's exciting to be involved in something that is both interesting, intellectually stimulating, and potentially very important.
Stephen Garrett has given himself just 2 years to prove that thermoacoustic refrigeration is a winning proposition.